So this lesson is about solving equations where we have the variable in the exponent. So we did some practice with this a few days ago, where if we look at an example here of a exponential equation, our x is in the exponent, so we have to make sure that we have the same bases here. So 3 to the x plus 1 and 81 we're going to write as a power of 3, and 3 to the fourth power is 81. And now, because our bases are the same, we can set our exponents equal to each other. So I have x plus 1 is 4, and subtract 1 on both sides, and x is 3. All right, so just a little bit of review of what we did a couple days ago. In example B, we have a lot of stuff here happening with e. So let's kind of clean this side up a little bit. On the left side, we have e to the negative x squared exponent, and then e to the x, and that quantity squared is e to the x. We're multiplying exponents, so e to the 2x. And this part right here, 1 over e to the third power, is the same thing as e to the negative third power. So if I combine this side, I have e to the 2x minus 3 equals e to the negative x squared. And now, because my bases are the same, I can set my exponents equal to each other. So negative x squared equals 2x minus 3. A quadratic equation, so I'm going to set this equal to 0. So I'm going to add x squared over here and say 0 equals x squared plus 2x minus 3. And I'll factor. So this would be x, and I would have a minus 1 and a plus 3, and that equals 0. So now I set each factor equal to 0, and x would equal 1, and x would equal negative 3. So this is absolutely just what we did the other day. So in part C, I have base e on each of these. So my exponents are going to equal 3x equals 2 minus x. Add x to both sides, so 4x equals 2. Divide by 4, and x is 1/2. In part D, which I noticed is the same as part H, so I'm just going to cross that off down here. But in part D, I have numbers 4, 2, and 16 as our bases, and each of these are powers of 2. So I got to get my bases to be the same number. So because 4 is a power of 2, I'm going to change this to 2 squared, which is 4, and this is to the x power. And then I have 2 to the x squared power. And then I have 16 squared, and 16 is 2 to the fourth power, and this now is squared. So my bases are now all powers, or are all base 2. So this becomes 2 to the 2x times 2 to the x squared power, and this equals 8, 2 to the 8th power. Now with a base of 2 in each of these, I can set my exponents equal. So this would be 2x plus x squared. I'm adding the exponents with the same base, equals 8. Okay, again, we have a quadratic equation, so I'm going to write that x squared plus 2x. I'm going to subtract 8 over to the other side, and that now is set equal to 0. And I will factor, and I have a positive 4 and a minus 2. And when I set each factor equal to 0, I have x is -4 and x is 2. And those are my solutions. All right, let's go ahead and do F. Again, I have e's as my base, so I'm going to set my exponents equal to each other. So this would be x equals 3x plus 8. And I'm going to solve for x here. So if I subtract x here, I'm going to have 0 equals 2x plus 8. I'll subtract 8. So 2x is -8, and x is -4 when I divide by 2. And I'm going to leave E and G alone, and we're going to do those in class before we work on our assignment, just as a bit of a review. But on the next page, now we have some problems that have logs in the problem, in the equation. And we're going to use the properties that we had to change these to exponential sentences. So I'm going to start with my base of 3. I'm going to square it. So 3 to the second power equals this part in here. So that's 4x minus 7. All right, so this is just 9 equals 4x minus 7. Add 7 to both sides, and I get 16 equals 4x. Divide by 4, and x is 4. All right, here's another one. Write the exponential sentence. So I have x to the second power equals 64. And I'm just looking for the number that I can square that gives me 64, and that is 8 if I square root both sides. Now on part C, here I have e to the 2x power equals 5. Now, when I'm working with base of a base e, I need to do the natural log to get the exponent out of the variable out of the exponent. So we're going to use a property that we use all the time, and it's basically what you do to one side, you're going to do to the other side. But what I'm going to do here is I'm going to apply the natural log of both of these. So this is e to the 2x, sorry, it was hard to see, equals ln of 5. So I just applied, or did, the natural log of both sides. On this side, I have a base e. Actually, there's two ways I can explain this. Let's go with, if I apply a log to an e, these are going to cancel out, because this is an exponent and this is a log, and they're actually inverses of each other. Just like if I were to multiply something by 4 and then divide by 4, I would still have my original number. So the natural log and the e are going to cancel out. And I'm going to have 2x equals ln of 5. So that's the natural log of 5. And we can actually find that value on a calculator, but we're just going to leave it in this form for right now. And to solve for x, we're going to divide both sides by 2. So x is the natural log of 5 over 2. And that's going to be our answer. Okay, there's another one below it on part E. To get my variable out of the exponent, I'm going to do the ln, the natural log, on both sides. So my ln and my e cancel out. I have 3x equals ln of 10, divide by 3, and x equals ln of 10 divided by 3. Let's do part D. On part D, here I have a log sentence, so I'm going to write the exponential sentence. So I have 3 to the second power equals 3x minus 2. 3 to the second power equals 3x minus 2. So this is 9 equals 3x minus 2. Add 2 to both sides, so that would be 11 is 3x. Divide by 3, and x is 11/3. All right, so on F, write the exponential sentence. 5 to the x power is 625. Okay, so I want to know what exponent would give me 625 with 5 as the base. So I'm going to count by 5. So 5 times 5, and I'm just going to count up here. 5 times 5 is 25, times 5 is 125, times another 5 is 625. So I multiplied 4 5s together, so x is going to equal 4. Let's do one more here. 2 to the negative third power equals 8 to the x power. So 2 to the negative third equals 8 to the x power. Now this is something that we did like on the other side. So I need to have the bases be the same so that I can have my exponents be the same. So 8 is 2 to the third power, and this is to the x power, and that equals 2 to the negative third. So basically, I'm going to have my exponents equal now. So negative 3 equals 3x. And when I divide by 3, x is negative 1. All right, so one more, and then we'll have a couple more that we can practice before we do our assignment. Now here, remember I said if you do a log, a natural log of e, they're going to cancel out. So if I were to cancel out the ln and the e, I have x equals 5. Okay, but we can also do it this way, where if I have the natural log, anytime I have a natural log, my base is e of, e to the x power equals 5. So if I write this as an exponential sentence, I have e to the 5 equals e to the x. And here we can see our exponents are equal, so x again equals 5. So that was just a couple ways of showing that. All right, so this is just lots of practice with solving log and exponential equations, and we're going to do some more work with that after we practice a few in class.